There we go. So last time we talked about how b affects our exponential graph. We took a look at two examples, y equals x to the exponent 2 to the exponent x and y equals 4 to the exponent x. In each example, our number of x-intercepts, y-intercepts, our range, our increasing or decreasing, and our domain were all the same. What the b value affected was the steepness of the curve. B value also affects the direction of the curve. So if we have a whole number as our B value, we're going to be increasing, and if the bigger our whole number is, the steeper our exponential curve is. The B value affects the steepness of the curve when our base is a fraction as well, fraction or decimal. If our base or B value is a fraction, our exponential curve will be going down instead of up. Our number of x-intercepts, y-intercepts, domain and range are all going to be remaining constant, but now we are decreasing, and the smaller our b value, the steeper our curve. Today we're going to be looking at how our a value affects our curve. So let's take a look at our first example. Y is 3 times base of 2 to the exponent x. We have one x-intercept at x equals positive 3. We have, no, not x-intercept, that is a y-intercept. One y-intercept at y equals positive 3. We have no x-intercepts. We are increasing. Our domain is x is any number that is real, and our range is y must be greater than 0. Not greater than or equal to, must be greater than 0. If we take a look at our second example, we still have 0 x-intercepts, but now our y-intercept is y is equal to positive 5. We're still increasing. Our domain is still x is any real number, and our range is still y must be greater than 0. If we compare these two graphs, we should notice that our y-intercept has changed from being 3 to being 5. The steepness of our graph has also increased because our y-intercept has increased. So how does A affect the graph? A affects the y-intercept and the steepness. And it affects the steepness because it changes the y-intercept. So in summary, was the relationship between the y-intercept and the array parameter. A is equal to our y-intercept. How can the y-intercept be determined algebraically using the equation? So just A is equal to the y-intercept. What happens to the exponential function if b is greater than 1? What happens to y values as you move from the left to the right on the y-axis? So when b is greater than 1, the exponential function is increasing. Okay. If b is a fraction or a decimal, our exponential function will be decreasing. Why does the graph have no x-intercepts? No value, no exponent will give us a 0 or negative value. Is the domain or range affected by the changing parameters in A or B? No. Let's take a look at a few more examples. We'll fill in these tables. Now that we have the basic rules, we can look at just the exponential function, and we should be able to predict its properties based on what we see. The y-intercept of this function, we have a base of 2, and if we have just the base, we can assume that that's going to look like this: 1, 2 to the exponent x. So our y-intercept here is 1. We have 0 x-intercepts. Our end behavior is quadrant 2 to quadrant 1 because we are increasing. Our domain is x is any numbers real, and our range is y is greater than 0. Here, similar story, 0 quadrant 2 to quadrant 1, x is any number that's real, range y must be greater than 0. Here, we're going to have a y-intercept of 5, number of x-intercepts is going to be 0. We're still going from quadrant 2 to quadrant 1 because our base is a whole number, therefore we are increasing. Our domain is still x is any number that's real, and our range is still the same. Let's take a look at our fraction examples. Here, again, we can rewrite this as y is equal to 1 times half to the exponent x, right? Meaning our y-intercept will be 1, number of x-intercepts is still 0, and behavior this time, and behavior is still the same. We still start at Q2 and go to Q1, right? So just because our exponential function is decreasing or increasing, it doesn't change the end behavior of the graph. Our domain is still x is any number that's real, and our range is y must be greater than 0. One thing I want to point out here is that the end behavior, I want to really highlight the end behavior because you can't tell if a graph is increasing or decreasing just based on its end behavior. In this example, our y-intercept is still 1, still 0 x-intercepts, and behavior is still Q2 to Q1. X is any number that's real, and y must be greater than 0. Here, we have changed our a value, so our y-intercept changes to 3, but everything else remains the same. Let's try this example here. I want you to fill in this section of the note, and then when you finish, click continue and check your answers afterwards. Alright, so let's go through the answers. The y-intercept is 1, this is false, and because we have a equals 8, meaning our y-intercept is going to be 8. Graph has 1 intercept, this is false because it's an exponential function. The range is y must be greater than 0, that's true. The domain is x must be greater than 8. This is false. We can have an x value of negative 30 and it would still work. So negative x values permitted. This is a decreasing exponential function. This is true, and this is because our b value is a fraction. Example 1, predict the number of x-intercepts, y-intercept, and behavior domain, and range for the following function. Use the equation of the function to make your predictions. Verify your predictions by creating a table of values and graphing the function. So use the equation here. So our base b value is e, our a value is 1, is an exponential function. So our x-intercepts is 1, our y-intercept is 0, so not applicable. Our y-intercept is 1, end behavior is q2 to q1, domain is x is any number that's real, and range is y must be greater than 0. Now, this is actually a special exponential function. It uses the base of e, which is Euler's number. We'll talk more about that when we use it later. This is going to come up a lot, though, in the next unit when we talk about logarithms. Logarithms can have different bases, just like exponents. Normally logarithms have a base of 10. That's what we're used to. But we're going to be using ln, symbol ln, which is going to have a base of e, which is why we need to go over it now. E is a number similar to pi. It's 2.17, but then it goes on forever, and similar to pi, it just doesn't stop. Right? It's a non-terminating, non-repeating number, making it a non-real number. So verify your prediction by creating a table of values and graphing the function. What I'd like you to do is I'd like you to put this into Desmos and just have a look at the table and the graph, and from there you will see that all of these predictions match up. Alright, give this question a try and we'll take it up in a few minutes. Alright, let's take up this question. So we have x-intercepts, that's not applicable, right? Because it's an exponential function, it does not have any x-intercepts. The y-intercepts is 2, because we have an a value of 2. The end behavior is q2 to q1, because it's an exponential function. The domain is x is any number that's real, and the range is y must be greater than 0. Verify your predictions by creating a table of values and functions. Put this exponential function into Desmos. Have a quick look at that graph. Use Desmos to convert that equation and graph into a table of values and verify your answer. Once you have done so, click continue and we'll go on to the next example. Example 2, predict the number of x-intercepts, y-intercept, and behavior. This one is identical to the previous one, except this one's going to be decreasing instead of increasing. As you can see, we have a b value of 2/3, so it's going to be decreasing. So let's see, x-intercepts, still not a thing with an exponential function. Y-intercept is 9, because we have an a value of 9. And behavior, still q2 to q1. Domain is still x is any number that's real, and range is still y must be greater than 0. The function is decreasing. On the previous example, did it ask for that? It did not. So the function is decreasing, and that's because our b value is less than 1. Have a look at that in Desmos. Once you've taken a look at that graph in Desmos and converted the function to a table, click continue and move on to the next example. Give this question a try and we'll take it up in a few minutes. Alright, so x-intercepts, again, not applicable. Y-intercept is 8 because we have an A value of 8. The end behavior is Q2 to Q1. The domain is x is any number that's real, and the range is y must be greater 0. This function is decreasing because we have a b value less than 1. Plug that equation into Desmos, verify using the graph and the table, and come back when you've done that. Alright, let's match the graph with an exponential function. So we have 4, 3, 1/3. Okay. So this one here, our b value can be a decimal or a fraction. We can convert I to a fraction. Y is going to be 3 1/5 to the exponent x. We have 2 that are increasing, both a and b are increasing, and c and d are decreasing. Just like with linear functions, the easiest way to identify which function is which is by its y-intercept. So here we have a y-intercept of 2, a y-intercept of 3, a y-intercept of 4, and a y-intercept of 4. So let's do a and c first. Which function has a y-intercept of 2? The graph of the y-intercept of 2 is number 4. Which graph has a y-intercept of 3? Function 1 has a y-intercept of 3. Now, both b and d have a y-intercept of 4. However, b is increasing and d is decreasing. Take a look at the functions above and see which one is increasing. Which one has a y-intercept of 4 and is also increasing? That would be function 2, because we have a b value, which is a whole number, and a y-intercept of 4, which leaves only 1, 2, 3 as our d value. Check your answers and move on to the next page. Give these questions a try, and we'll take it up in a few minutes. Okay, so a is decreasing and it has a y-intercept of 1. So we need a base that is a fraction, which is number 3 or number 4, and a y-intercept of 1, which makes it function 4. B is increasing the y-intercept at 1. So we need a base that's an a value of 1 and a whole number as our base, which is function 1. C is increasing with a y-intercept of less than 1. Okay. We've already used 4 and 1. If we look at 2 and 3, we have a x-intercept, or y-intercept, sorry, that is 1/3, which very much looks like where that graph is intercepting the y-axis, and this has a base which is a whole number, which matches what we see on our graph. This means that that is function 2, leaving only function 3 here. Function 3 is decreasing with its b value less than 1 and as an x-intercept of 3. Read the summary and key ideas. Complete these practice questions. If you have any questions, feel free to email me or ask me in class.